deaths of the stars seem impossibly remote from human experience. And yet we're related in the most intimate way to their life cycles. The very matter that makes us up was generated long ago, far away, in red giant stars. The formation of the solar system may have been triggered by a nearby supernova explosion. After the sun turned on, its ultraviolet light poured into our atmosphere, its warmth generated light, and these energy sources spawned the origin of life. Plants harvest sunlight, converting solar into chemical energy. We and the other animals are parasites on the plants. So we are, all of us, solar power. Think of the sun's heat on your upturned face on a cloudless summer's day. From 150 million kilometers away, we recognize its strength. What would we feel on its seething, self-luminous surface, or immerse in its heart of nuclear power? And yet, the sun is an ordinary, even a mediocre star. Our ancestors worshipped the sun, and they were far from foolish. It makes good sense to revere the sun and the stars, because we are their children.
in one star can influence a world halfway across the galaxy in a billion years in the future.
All life on the planet are under here by chance. 99% of all the species that ever existed were wiped out in a series of global catastrophes. Disasters that changed the course of evolution. 250 million years ago. The largest volcanic eruption the planet had ever seen. Nearly erased all life on Earth. If you think about it, the human body is a mechanical system, which is an engine involved with force and movement. Like any other mechanical system, there is a certain level of wear and tear that occurs. Not only are the forces being applied to it causing damage, like a piece of plastic that is bent, never bends back to the same shape. Also wear with time. obsolescence. Some devices have a very dragon lifespan. They do not rely on some random part to fail, but instead are designed to fail, accumulate, or have a certain number of uses.
The human body is subjected to the constant pull of the Earth's gravity. As a result, its systems are designed to function efficiently in an Earth gravity environment. Suddenly deprived of this lifelong stimulus, the astronauts' bodies must adapt to their newfound weightlessness. Signs of this adaptation will appear within the first few hours of the flight. Among the first changes they will notice are a sensation of fullness or pressure in the head, eyes, and sinuses, often accompanied by a headache. Facial edema or puffiness and distension of veins in the head and neck. A dramatic decrease in leg size, a condition sometimes described as the bird legs of space. These symptoms reflect a redistribution of body fluids brought about by the absence of gravity. To understand why this occurs, imagine the body as a column of fluid. Under the influence of Earth's gravity, the pressure at the bottom of the column is greater than the pressure at the top. This pressure difference is known as the hydrostatic pressure gradient. As the body becomes weightless, the pressure equalizes between the top and bottom of the column, and fluid is redistributed upward. The resulting increase in fluid in the upper body and the decrease in the lower body produce the symptoms previously described. Roughly half of the crew members will experience varying degrees of a syndrome that has been dubbed space motion sickness, or SMS, with symptoms ranging from mild stomach awareness during head motion to violent bouts of nausea and vomiting. Space motion sickness has been called the most clinically significant medical phenomenon during the first 4 days of spaceflight. Symptoms usually begin with the first 6 hours of flight and resolve by the 3rd day of flight. Symptoms most commonly reported include loss of appetite, vomiting, stomach awareness, malaise, headache, and lethargy. The most puzzling thing about this malady is that there is no apparent correlation between the incidence of SMS and susceptibility to motion sickness experienced on Earth. A crewman that is highly resistant to sea or air sickness on Earth may become violently ill in space, or vice versa. Known motion sickness medications seem to have little effect, making SMS an unpredictable nuisance for which there is no treatment. The astronauts will note another change within 1 day after launch. They will each be more than an inch taller than they were on Earth. Their spinal columns and the supporting musculature will expand like compressed springs being released.
He's probably lost a liter or a liter and a half of fluid.
These amazing responses to spaceflight are but the tip of the iceberg of physiological adaptation. A host of other changes, many of which have yet to be discovered, take place as man adapts to this unique environment.
Figure out what happens.
Observations of such changes raise questions about the mechanisms involved and about the body's ability to function properly in space and upon return to Earth. What causes space motion sickness? Can it be treated or prevented? How does the cardiovascular system cope with the massive shift in body fluids? What other physiological changes take place as a result of exposure to weightlessness? What are the implications of these changes for long-duration space travelers? What steps need to be taken to ensure the health and well-being of future astronauts? Man's spaceflight experience from the Mercury, Gemini, and Apollo programs had demonstrated that man can live and work in space for days and weeks at a time. The Skylab program proved the viability of missions lasting several months. The scientific data collected during these programs answered many basic questions about the effects of spaceflight on human physiology. But even more new questions were raised than had been answered. The arrival of the shuttle era ushered in more routine access to space and paved the way for the space station, making the search for answers to these new questions even more pressing. The design of the space shuttle vehicle raised particular concern about the effects of fluid shifts on the cardiovascular system. The hydrostatic pressure his heart will have to work harder to maintain an adequate blood supply to the brain. If it cannot keep up, a blackout or fainting spell can result. This reaction to spaceflight is called cardiovascular deconditioning. In all previous spacecraft, astronauts re-entered the atmosphere lying on their backs. Thus, the hydrostatic pressure gradient didn't become a factor until they climbed out of the capsule and stood up. The shuttle, however, is flown to a landing like an airplane. The astronauts sit upright during re-entry and immediately feel the effects of the pull of gravity on their cardiovascular system. Another concern for shuttle operations was the possibility that an astronaut suffering from SMS might be incapacitated in the event of an emergency landing early in the mission. It was clear that space motion sickness and cardiovascular deconditioning had immediate operational significance, and that the search for preventative measures and treatment for these syndromes should be given a high priority. The personnel, facilities, and expertise at the Space Biomedical Research Institute enable us to remain at the forefront of space adaptation research. The valuable data we have collected from our ground-based and in-flight investigations have yielded a wealth of information on physiological adaptation to the space environment. We will continue our efforts to make man's steps into space safer and to ensure his health and well-being upon return to Earth. We will continue looking for answers.
Commander Arkan. Sure, Cap. We just received a stat clear message. Roger. Arkan Commando, verify command stack loaded. Block message number 9. First command, IP Whiskey 2 times 1410 32 decimal 8. Roger, copy. We're enabling the extended time.
Now picture, if you will, a fantastic world where not one, but 12 moons crisscross the sky. This is Jupiter, largest member by far of the Sun family, monarch of the outer planets, 1,000 times the size of Earth. Jupiter, named for the Roman god of gods. Hydrogen and its compounds, same kind of atmosphere that the Earth had at the time of the origin of life. And Jupiter may be a vast planetary laboratory that's been working for about 5 billion years.
From the outside, you can't tell what is inside a black hole. Quantum mechanics implies that the whole of space is filled with pairs of virtual particles and antiparticles that are constantly materializing in pairs and then coming together again, annihilating each other. Particles and antiparticles annihilating each other. Particles may fall into the hole, leaving the other member without a partner with which to annihilate. The forsaken particle or antiparticle may fall into the black hole after its partner, but it may also escape to infinity, where it appears to be radiation emitted like a black hole. Black holes ain't as black as they are painted. They are not the eternal prisons they were once thought. of a black hole, both to the outside, and possibly to another universe. So, if you feel you are in a black hole, don't give up. There's a way out.
Transhumanism is the idea that man is merging with technology. Will robots inherit the earth? Yes, they will, but they will be our children. This means everything from bionic limbs, brain implants, artificial intelligence, to even someday uploading our minds to the internet. Transhumanism is the future of connectedness. It is technology as an extension of ourselves. Now, I believe that the pace of technology will evolve to the point where biology will become the limiting factor. The Internet of Things has already begun. And the real power comes when these devices begin to talk to each other. Soon thereafter, you won't just wear technology. You'll ingest it. Eyes, with zoom capabilities, infrared sensors, and night vision will be possible. And the prosthetic limbs of the future will be even more flexible and powerful than our original organic limbs together. Retinal implants in a few years will allow the blind to see and recognize faces. And there are already arms that are controlled by human thought. The beginning of the age of mind reading. Seeing through another person's eyes. It's your very own augmented mind. Chips won't just be in your laptop or your phone. Doctors will implant them in our brains, and they'll restore sight to the blind and hearing to the deaf. The brain net, a form of virtual telepathy. But it's hard to imagine where these advances take us as a species, because we're only able to observe these small incremental steps along the way. these ideas maybe are a bit spooky. That's simply human nature. And there are certainly ethical and moral dilemmas that we'll face as we go through this process. But that all changes with the children of today.
Information technology grows exponentially. So these technologies will be 1 million times more powerful within 20 years. The speed of exponential growth is itself speeding up. So in 25 years, these technologies will be 1 billion times more powerful than they are today.
Progress is accelerating at an exponential pace, and it's going to reach a point where progress is so fast it's going to be a singularity in history. Computers are getting smaller and smaller. We'll have nanorobots at the size of blood cells that have computers in them that go into the brain through the capillaries. That will communicate wirelessly to the cloud. By 2029, computers would have all of the intellectual and emotional capabilities of humans. The pace of the exponential growth of information technologies like computation, communication, simulating biological processes, will have the computational capacity to functionally simulate the human brain. One thing that gives me comfort is we don't have 1 or 2 AIs in the world. We have 2 or 3 billion AIs.
By 2029, we'll have reverse engineered the human brain.
Computers, very gradually, they'll become more and more human-like, to a point where they're really indistinguishable.
And computers at that time will be far more powerful than the human brain. And we'll be able to create machines that really do have the subtlety and suppleness of human.
We are spiritual machines. Nanorobots have
reverse engineered the human brain. It's not some alien invasion of intelligent machines. From Mars to invade us. It's coming from within our civilization. The whole point of it is to extend our reach. The singularity is not just that point where we achieve human level of intelligence in machines. That will start a new revolution. They'll be able to actually improve their own software design. By 2045, we'll have expanded the intelligence of our human-machine civilization 1 billion-fold. That will be a singularity.
Seconds and counting. Astronauts report it feels good. T-minus 25 seconds. 20 seconds and counting. T-minus 15 seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence starts. 6, 5, 4, 3, 2, 1. 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
Roger, we got a roll from
Tower clear.
Roger, roll. ignition and the thrusters go. Apollo 11, this is Houston at 1 minute. Trajectory and guidance look good and the stage is good. Over. Apollo 11. 35,000 feet per second. Turning velocity 35,570 feet per second. Altitude 177 nautical miles. Roger, 11, we'll pass that on, and it's going to look like you're rolling your way now. Apollo 11, this is Houston, clear up the feet per second. Now at the altitude building, 512 nautical miles. All 11 is Houston. All the booster functions are proceeding normally. The sequencing is in good shape. Doesn't look like they have any problems at all.